Hello everyone, myself Ved, and today we will be solving biweekly contest 183, question number 1. Let us read this question. So, you are given an array, integer array nums. Okay. Now, in one operation, you can choose two distinct indexes, I and j, and swap num of I and nums of j. Now, we have to return the minimum number of operations required to move all zeros to the end of the array. Okay. So this is a little bit easier question. So let us try to understand this question through this example. Okay. So we have given this example, 0, 1, 0, 3, and 12. Okay. Now what we have to do is we have to tell minimum number of operations that we can do, like minimum swaps that we can do to make sure that it comes to the end of the array. So the answer should be like this. What we can do is we will swap this 0 with this 12. Then we will get 12, 1, 0, 3, and 0. Okay. Now after this, we will swap this 3 with 0. Okay. So now we will get 12, 1, 3, 0, and 0. Okay. So see, we got both the zeros at the end. So how many steps we took? 1 and 2. So output would be 2 because the minimum number of steps that we took was 2 to make sure that all the zeros are at the end of the array. So the answer is 2. See, here also output is 2. So we have to determine this. Okay. So now we have to take care of few things. For this problem, we have to take care of few things. So let's say if we get some examples, something like this: 1, 5, 1, 4, 2, and 0. Okay. So now here the output would be 0 because all the zeros are already at the end. Okay. So output would be 0. So we have to take care of this condition because there might be a situation like 0, 5, 4, 2, 0. So at this point of time, this 0 is at its own place. Okay. We don't have to hinder this position. We have to change, we have to swap this with this, and uh we will get 2, 5, 4, 0, and 0. So now here the total minimum number of steps was 1. We won't be doing something like this, that firstly we will swap this 0 and then we will swap this. No. That would take two operations, but we have to determine the minimum number of operation to make sure all the zeros are at the end of the array. So now let us try to get some conclusion over this problem. So what we can do is, firstly, we can count the number of zeros that are present in the array. So what we can do is, let's say if we get something like this, 5, 1, 0, 2, 0, 3, 0. So now firstly we will calculate the number of zeros that are present in this whole array. So 1, 2, 3. 1, 2, 3. There are three zeros. So we will store it inside a variable. Okay. So count would be 3. It would represent the number of zeros that are present in the array. Now what we are going to do is we will iterate through the entire array from the back. So we'll iterate it from here. So let me again write this array. Uh, 5, 1, 0, 2, 0, 3, 0. Okay. Now what we are going to do is we will iterate through the entire array from the back. So we will firstly come on to this position. Okay. And now if we find a 0 here, okay, so what we are going to do is we will reduce the counter variable. So we will reduce the number of zeros that are present here. Okay. So from 3 it would be 2. Okay. And after that we will move to the next index. Okay, we will move here. Now if it is not 0, then what we are going to do is we will take one more variable and we will increment this counter. This will make sure to calculate the number of operations that we are going to need to make sure all the zeros are at the end. So we will increment this. So indirectly what we are going to do is we will take this index which is not 0. Okay, this element is not 0, and we will find the index the element which is 0 from the left. So this is 0. Okay, nearest element which is 0 from the left. So this is 0 and this is not 0. And we will swap both the indices. We will swap these two indices. Okay. So we won't do it we won't be permanently changing into the array. What we are going to do is we will hypothetically think of that we have changed something in the array, and we will increment this CHE counter, which will make sure to count the minimum number of operations that we need to make sure all the zeros are at the end. So this will make sure to like this will make a array something like this: 3, 2, 0, and 0. And again, it will decrease this counter because now we have got 0 at this position as well. So now it will be 1. Okay, now it will move to the next index. So now here see it is 0. So it won't increment this counter. Here it is 1. Okay, now it won't increment this counter. It will direct decrement this and make it 0. And whenever it is 0, we will be breaking out of this loop. So now we will be outputting it as CHE. We will output CHE, which is 1. And we got our answer. Okay, so now let us try to see the code, like how to implement this question. See, firstly, I took the variable which calculate the size of the array, then a CHE counter which is initially 0. Then, if I calculate the number of zeros that are present in the array, after that, I initialize one more variable known as CNT. And if CHE, which is if there is no zero present in the array, then we will return it as 0 because there is no zero. So we cannot make any operations to make all the zeros at the end because there are no zeros present in the array. Okay. After that, I initialize the loop from the end, okay, from the end to the starting, where if the particular element is equals to 0, then I decrement the number of count, like the number of zeros that are present in the array, okay. I decremented that. And if it is not 0, then I am incrementing this counter, okay, which will make sure to, like, it will hypothetically swap two elements in the array and it will increment the counter, okay, because we need minimum number of operations. And at the same point of time, it will also decrement the number of elements, like a number of zeros that are present in the array, okay. And after that, at the end, if ch is equals to 0, which basically means we have make sure that all the zeros came at the end, okay. And if that, like if that is true, then we will break out of this loop, okay. And at the end we will return the count, like cnt, which makes sure to give us minimum number of like the minimum number of operations to make sure all the zeros are at the end of the array, okay. So let us try to run this question and let us just submit it. So yeah, this was the solution of weekly contest 183, question number 1. Thank you.